Namaste. My name is JVN Manisha Singh, Assistant Professor in Department of Food and Biotechnology under Faculty of Agriculture and Veterinary Sciences in Jyoti Vidyapeeth Women's University, Jaipur. I am teaching you subject Unit Operation in Food Industries and for class BSc FST second semester, BTech FPT second semester. In today's session, we will discuss all about the size reduction. So, what is the size reduction? Size reduction is basically a process of reducing the large solid particles unit masses into the small unit masses. Okay, coarse particles to the fine particles. This is known as size reduction. Size reduction process is also termed as comminution, diminution, pulverizations. Okay, so solid pieces of food is reduced by the application of grinding, compression, or by impact forces. In many food processes, it is frequently necessary to reduce the size of the solid materials for the different purposes. Next is, what is the benefits of size reduction in food processing? Basically, it increases the surface area to volume ratio of the food. It increases the rate of drying, increases the rate of heating or cooling, improves the efficiency and rate of extraction, facilitating mixing and blending, and facilitates heat exchange, chemical and biological reactions. Then what is the classification of size reduction? Like cutting, chopping, slicing, and dicing. That is, large to medium is for stewing, steak, cheese, and sliced fruit for canning. Medium to small is sliced green beans and diced carrots, and smaller to granular may require minced or shredded meat, flaked or fish or nuts, flaked fish or nuts, and shredded vegetables. Okay. Next is uh, milling to powders or paste of increasing fineness. Examples are the grated products, spices, flours, fruit nectars, powdered sugar starches, and smooth pastes. And emulsion and homogenization is for milk, essential oils, butter, ice, cream, and margarine. Then what are the forces used in size reduction? The types of forces commonly used in the food processes are compressive, impact, attrition, or shear and cutting. Okay, in the comminution operation, more than one type of force is usually acting. For example, crushing, grinding, and milling take place in powdered sugar, flour, mustard, and cocoa production. Compressive forces are used for coarse crushing of hard materials. Impact forces can be regarded as general purpose forces, and shear or attrition forces are applied in fine pulverization when the size of products can reach the micrometer range. Next is the ultra fine grinding is associated with the processes in which the submicron range of particles is attained. Cutting gives a definite particle size and even produce a definite shape. Okay, then what is the mechanism of size reduction? In the grinding process, materials are reduced in the size by fracturing them. In this process, the material is stressed by the action of mechanical moving part in the grinding machine. And initially, the stress is absorbed internally by the material as a strain energy. Stress strain, which will lead to fracture in lines of the weakness, and that will release the heat. Some of the energy is taken up in the creation of the new surface, but the greater part of it is dissipated as heat. Then energy required for size reduction. Energy required basically depends upon the two parts, the hardness of the material and the tendency of the material to crack, basically friability of the material. The minimum energy required or needed to rupture the material. Excess energy is lost as heat, and this loss should be kept as low as practicable. Okay, the energy should be kept as low as practicable. Figures of less than 2% efficiency have been quoted. Thus, grinding is very inefficient process, perhaps the most inefficient of the traditional unit of operations. Much of the input energy is lost in deforming the particles within their elastic limits and through interparticle friction. A large amount of this wasted energy is released as heat, which in turn may be responsible for heat damage of the biological materials. Grinding is very inefficient process and it is very important to use energy as efficiently as possible. Three theories depends upon the basic assumption that the energy required to produce a change of dl in a particle of a typical size dimension L is a simple power function of L. So dE by dL is equal to K raised to power Ln, where d is the differential energy required, dl is the change in a typical dimension, L is the magnitude of the typical length dimension, and K and N are the constant. The energy required to reduce the size of the solid foods is calculated by using one of the three equations as follows. Number one is the Kick's law, Rittinger's law, and the Bond's law. Kick's law basically, Kick reckoned that the energy required for a given size reduction was proportional to the size reduction ratio, and the value of the power is N as 1. In such a way, by integration of the following relation, which is known as a Kick's law, is obtained, in which E is equal to K ln of x1 by x2, where x1 and x2 is the size reduction ratio. Kick's law has been found to hold more accurately and coarser crushing, where most of the energy is used in causing fracture along existing cracks. Next type of law is Rittinger's law, and he is considered that for the grinding of solids, the energy required should be proportional to the new surface produced. The power n, the value of 2. Okay, thus obtaining the so-called Rittinger's law by integration of equation E is equal to K under bracket 1 by x2 minus 1 by x1. And E is the energy per unit mass required for the production of a new surface by reduction. And K is also known as Rittinger's constant. X1 is the average initial feed size and x2 is the average final product size. Rittinger's law has been found to hold better for fine grinding, where a large increase in surface results. Bond's law and work index. It is a third version of commutation law is the one attributed to Bond, who considered that the work necessary for the reduction was inversely proportional to the square root of the size produced. In Bond's consideration, N takes the value is 3 by 2 and A is equal to 2K in brackets 1 by under root x2 minus 1 by under root x1, where x1 and x2 are measured in micrometers and E is kilowatts per ton. Okay, so K is equal to 5 EI, where EI is the bond work index defined as the energy required to reduce a unit mass of material from an infinite particle size to a size about such that 80% passes 100 micrometer C. Okay, next is the size reduction equipments. The principal types of size reduction machines are crushers, coarse or fine, jaw crushers, gyratory crushers, crushing rolls, etc. Next type is grinders, that is intermediate and fine, which includes the hammer mills, impactors, rolling compression mills, attrition mills. And next is ultra fine grinders, hammer mills with internal classification, fluid energy mills, agitated mills, and the ball mills. And fourth type is cutting machines, which includes the knife cutter, dicers, and splitters. Okay. So crushers are jaw and gyratory. Crushers draw material down into the progressively narrower space, resulting in a size reduction. However, they are not extensively used in the food industries. Next type of mill is hammer mills. Hammer mill, which contains a high-speed rotor turning inside a cylindrical case. The rotor carries a collar bearing a number of hammers around its periphery. By the rotating action, the hammers swing through a circular path inside the casing containing a toughened breaker plate. Feed passes into the action zone with the hammer driving the material against the breaker plate and forcing it to pass through a bottom mounted screen by gravity when the particles attain a proper size. Next is the reduction is mainly due to the impact forces in the hammer mills. The hammer may be replaced by the knives or any other device to give the mill the possibility of handling tough, ductile, or fibrous material. The hammer mill is versatile piece of the equipment that gives high reduction ratio, and it handles a wide variety of materials from hard and abrasive to fibrous and sticky. In the food industry, extensive use for grinding spices, sugar agglomerate, dry fruits, and dry vegetables. Okay. Next is the attrition mill. Attrition mills are also known as the plate mills or the disc pulverizers and are widely used for small scale milling. Sorry. These mills use the working principle of the shearing and cutting actions, and the material is fed in between two circular plates with the fluid or roughened surface. On the plates is fixed while the other one has a rotation facility. Normally, the material is fed near the axis of the rotation and is sheared and crushed. Okay. These mills produce a narrow range of the particle sizes. The low clearance and higher speed facilitate the production of finer size particles. The plate mills led to a development of the colloid mill. The main difference between them is clearance between the plates and the speed of rotation. These mills are extremely used like shred, curl, granulate, grind, shear, twist, blend, rub. Okay, next type of mill is tumbling mill or a ball mill. The tumbling mill is used in many industries for fine grinding. It basically consists of a horizontal, slow speed rotating cylinder that is partially filled with either balls or rods, and the cylinder shell is usually made up of steel lined with carbon steel plate, porcelain, silica rock, or rubber. The balls are normally made out of steel or flint stones, while the rods are usually manufactured with the high carbon steel. The tumbling mill or the ball mill, basically the cylinder in which rotates, the grinding medium is lifted up the sides of the cylinder and dropped onto the material being comminuted, filling the void spaces between the medium. The grinding medium component also tumble over each other and exerting a shear action on the feed material. The combination of impact and shearing forces brings about a very effective size reduction, as a tumbling mill basically operates in a batch manner. Next type of machine is cutting machine, which is required for slicing, flaking equipment, and dicing equipment, shredding equipment, and pulping equipment. Okay, so slicing and dicing, basically blade slides by centrifugal force and each slice falls away freely, and vegetables, fruits, and meats are first sliced and then cut into the strips by rotating blades. And the strips are then fed to a second set of rotating knives that operate at a right angles to the first set and cut the strips into the cubes. Okay, next is shredding. Commonly, they are the modified forms of a hammer mill in which knives are used instead of hammers to produce the cutting action. A second type of shredder, known as the squirrel cage disintegrator, has two concentric cylindrical cages inside a casing, and they are fitted with knife blades along their length, and the two cages rotate in opposite direction. Food is subjected to powerful shearing and cutting forces as it passes between them. Next cutting operation is pulping, and it is a combination of compression and shearing forces are used for juice pulp extraction from the fruits or vegetables and for producing pureed and pulped meats. Okay. Next is the homogenization. This is the unit operation that prevents the fat globules from coalescing into a cream is called homogenization, which is also a way of size reduction in the liquids. And the liquid formulation is forced through a small opening at higher speeds, breaking down the fat or other globules into a smaller ones. High speed mixtures is the edges and the tips of the blades in high speed turbine propeller type mixtures impart a shearing action on the low viscous food formulations to homogenize into a smooth homogeneous emulsion. Okay, for which turbine blade, stator rotor impeller, and folding propeller blade and pitch blades are used. Then processor homogenizers. Pressure homogenization is conventionally done prior to pasteurization and ultra high temperature UHT sterilization. Pressure homogenizers use a high pressure pump operating to 100 to 700 bar, which is fitted with a homogenizing valve, that is two-stage homogenization on the discharge side. When the liquid is pumped through the small adjustable gap between the valve and the valve seat. The high pressure produces a high liquid velocity, that is 80 to 150 meters per second. An instantaneous drop in the velocity occurs as the liquid emerges from the valve. And this extreme turbulence produces powerful shearing forces, and the droplets in the dispersed phase become disrupted. The collapse of air bubbles and impact forces created in some valves by placing a hard surface in the path of the liquid further reduces the globule size. Next type of mill is colloid mills. Colloid mills are more effective than the pressure homogenizers in creating high shear and are meant for high viscous liquids. They are essentially vertical disc mills with a narrow gap between the stationary and rotating disc in the range of 0.05 to 1.3 mm and rotate at 3000 to 15,000 rpm. Numerous designs of disc including flat, corrugated, conical shapes and even carborundum are available for different applications. The greater friction created during size reduction of high viscous foods may require these mills to be cooled by circulating water in the water jacket. Next is ultrasonic homogenizers. A high frequency sound wave in the range of 18 to 30 kilohertz is used in ultrasonic homogenizers and cause alternate cycles of compression and tension in low viscosity liquids. It is also responsible for cavitation of air bubbles to form emulsions with droplet sizes of 1 to 2 micrometer. And this type of homogenizer is used for the production of salad creams, ice creams, synthetic creams, baby food, essential oil, and emulsions. Okay. So from this session, the questions may be asked in your final exam like, what is size reduction? What is the principle of size reduction? What are the benefits of size reduction? And explain the different equipments used for the size reduction. Okay. So likewise, questions will be asked in your final exams. So answers them accordingly. I hope this session is clear to all. Thank you so much for watching this video.